So we talked yesterday about having the limit as x approaches a number. And we talked about coming at the function from both directions. We talked about coming at the function from both directions. And so we can actually break that down into coming from each of the directions. So the notation here is that this is approaching from the right. And if I have a little negative up there, then we're approaching it from the left. And in other words, from the right, how you can remember which one's which is this has got a little plus above it. And so that means that we're looking at something coming at the number from the positive direction. So we're looking at approaching one from the right, from the positive direction. And then this is approaching one from the left, from the negative direction. As x gets closer and closer to 1, what's happening to y? So that's the notation of limit from the left and limit from the right. This is on the last page, by the way, in the notes. That's where I'm at. So based on the graph that I just drew, you're determining whether those statements are true or false. So part A. Limit as x approaches -1 from the right. As x approaches -1 from the right. So I'm coming to -1 from the right-hand side and looking at what y value it gets closer and closer to. And what the statement says is that the y value, as I'm coming from the right, the y value is getting closer and closer to 1. True or false? That's true. This is true. Next one. Limit as x approaches 0 from the left. These next two are both asking about the limit as x approaches 0 from the left. And one of them says it's 0, one of them says it's 1. So I'm coming to 0 from the left. What y value is it getting closer and closer to from the left? So what we talked about yesterday is that it's not about that's not the same as asking what is f of 0. That's a different question. That's different from what is the value of the function at 0. What I'm asking is if I come to 0 from the left and get really, really close to 0, what y value are we getting closer and closer and closer to? We're getting closer and closer to 0. So the limit as x approaches 0 from the left is 0 and not 1. So again, asking what the limit is different from asking what the value of the function is. The limit is asking if I'm getting very close to that number, what is the area around it behaving like? What are we expecting the value to be ordinarily? Next question is asking, limit as x approaches 0 from the left and limit as x approaches 0 from the right. Are they equal? In other words, we just said that from the left, the y values are getting closer and closer to 0. Is that what's happening from the right side? Yes, it is. So from the right side, the y values are getting closer and closer to 0 as we approach 0. Which means, as we'll talk about in a second, that the limit has to exist. And the limit as x approaches 0, that means it's going to be 0 and not 1. And I want to jump down here. The last question. Limit as x, we'll come back to these two in just a second. The limit as x approaches 2 from the left. Because I don't approach it at all from the right-hand side. I only approach it from the left-hand side. So as I come to the x value of 2 from the left-hand side, what's the y value getting closer and closer to? It should be 0. Because if I'm coming to 0 from the left-hand side, then the y value should be closer to 0. So this is false. Limit as x approaches 2 from the left. This should be 0 and not 2. In fact, it should be pretty straightforward. It's staying at 0, it's staying at 0. As I get closer and closer to 2, it's still at 0, still at 0. So we're getting closer and closer to 0. So that's what we talked about yesterday. We left off with this example. And basically we had this line everywhere except at 2. And we talked about how the limit as x approaches 2, even though we're saying that f of 2 is 0, that doesn't matter. What matters is what's happening around 2. And as I'm coming at it from the left-hand side and the right-hand side, we're getting closer and closer to 5. The y values are getting closer and closer to 5, if I were to graph that. So that's that idea of a limit. I think I might have talked to you guys about Zeno's paradox. The idea of the turtle racing and always getting halfway there. And we get halfway another time, so now we're another quarter of the way, then we're another eighth of the way, then we're another 16th of the way. And we talked about how they never will actually get to the finish line because they're always getting halfway closer. But there's this idea that, well, of course they would get to the finish line eventually, but it would take an infinite amount of time. That's kind of the idea of a limit is, well, it doesn't really hit 5, so how do we know to put the open circle at 5? Well, because if I were to zoom in infinitely close, that's the value that it's zooming in on. That's another way to express that idea. Okay. Now, right, okay. So that's a limit. Those are some examples of how we can find a limit. But there are some times when we cannot find a limit, and the limit does not exist. So that's what we're going to talk about today, a limit not existing. A limit does not exist if the function approaches a different number from the right side than it approaches from the left side. If we're conflicting on which direction we go from, then the limit's not going to exist. Number 2, f of x increases or decreases without bound as x approaches c. If you're saying what number do we get closer and closer to, and the answer is something like infinity, well, infinity is not a number. Limit's got to be a number. And then f of x oscillates between two fixed values as x approaches c. So if you can't tell what y value we're getting closer and closer to, then the limit can't exist. Okay. We're going to look at examples of each of these three things. So let's start with the first one. The first one is the most common one. This is the most common case of a limit not existing. So I'm going to give you, must have the same result approaching from both sides. If it's different, the limit does not exist. Here's an example. I'm going to give you 2 minutes. I want you to try and make the graph of this function. Plug in 1. What are we going to get? It's going to be 1, because I have 1 over 1 is 1. Plug in 2, what do we get? 1. We have 2 over 2. It's still going to be 1. It's going to be absolute value of 3 is 3 divided by 3 is 1. Plug in 80,000, what are we going to get? Still 1. Plug in a half, what are we going to get? A half over a half, still 1. Plug in 0, what do we get? Doesn't exist. Uh-oh. Error. What if we plug in -1? Careful on this one. On top, absolute value of -1 is 1 over -1 is going to be -1. Plug in -2, what do we get? Absolute value of -2 is 2 over -2 is -1. Absolute value of -3 is 3 divided by -3 is -1. So here's what's happening. On the left, let's say this is -1 and this is +1. From the left side, all these values are -1. No matter what I plug in on the negative side, I get -1, -1, but 0 I get an error. As soon as I hit 0, it doesn't work. On the right-hand side, if I plug in 1, I plug in 2, I plug in 3, all that's fine. I get a +1. So the idea here is limit as x approaches 0 from the left. If I'm approaching 0 from the left, what is it? What y value am I getting closer to? From the left side. From the left side, I'm attacking it from the left. What y value? It's -1. And the limit as x approaches 0 from the right, over on the right-hand side, +1. These don't match. If I'm asking what y value we're getting closer to, well, it depends on the direction I'm coming at x from. That's a problem. So that's why the limit doesn't exist. Limit does not exist. Since the limit of the function from the left is -1, the limit from the right is +1. Since these are not the same, the limit does not exist. In other words, the shorthand, lazy way of writing that is to say the limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right of f of x. What happens if I plug in, because we're looking at very close to 0. What happens when I plug in something very, let's say I plug in a fourth. A fourth squared, 1/16. So 1 over 1/16 is going to be 16. Let's say I plug in 1 over a million. 1 over a million squared is going to be really tiny. And then if I take 1 over that really tiny number, I'm going to get a huge number, right? So what this graph looks like, something like this. It's going to have some asymptotes, most notably, for our purposes, at 0. When I say it increases or decreases without bound, this is what I mean. If I looked at what value am I getting closer and closer to from the left and from the right, you'd have to answer, well, infinity. But infinity isn't a number. I got to get closer to a number for the limit to exist. So if I'm talking about increasing or decreasing without bound, that's what we're talking about. Since f of x increases without bound as x approaches 0, the limit does not exist. So that's case number 2. So we come to different directions from the left and from the right. That's not the problem here. From the left and from the right, we're getting to the same thing. It's just not getting to a number. Case number 2, increasing or decreasing without bound, getting closer to infinity. Then we have a problem. Case number 3, how about your calculator and graph that next example? And try to get, if you have a minute, we're not going to have time today, but see if you can get out, we practiced a lot of trig. See if you can get out the table of values that we plug in there. With 2 over pi, 2 over 3 pi, 2 over 5 pi. These are getting closer and closer. These are getting closer and closer to 0, right? 2 over 9 pi is bigger than 2 over 11 pi. These are getting smaller and smaller and smaller and smaller. So we're getting closer and closer and closer to 0. We're trying to study what we get closer and closer to. And what you'll see, okay, is that if I take the sign of, well, this will get flipped since it's 1 over x. Watch up here for just a second. This will get flipped since it's 1 over x. So really this is asking for the sign of pi over 2, which is 1. This will get flipped. It's asking for the sign of 3 pi over 2. 1, -1. This is just going another 2 pi. 1, -1. And this is going to keep going forever. I could do 2 over 13 pi. It's going to be 1. 2 over 15 pi is going to be -1. Even as I'm getting closer and closer to 0, it keeps bouncing between 1 and -1. I'm going to go zoom 7 for zoom trig. And this is the other case where the limit doesn't exist. I'm going to zoom in a little bit so you can, yep, zoom into 0, 0. We're looking at what's happening as we're getting closer and closer to 0. Oh boy. As I get closer and closer to 0, what's happening to y? Well, it's really hard to tell. What value are we getting closer and closer to? I don't know, because I'm bouncing between that 1 and -1, even as I get closer and closer to 0. This is the other case where our limit is not going to exist. Because we're oscillating, we're bouncing infinitely fast between -1 and +1. This is not as common. But it does come up. More common is going to be the idea that where we're approaching from the left and where we're approaching from the right disagree, or where we're approaching basically infinity or negative infinity. That's the idea of the limit not existing. Tomorrow, 1 o'clock. If you have any questions, if you're lost on anything, if you want to go over something, tomorrow at 1.